Okay, we've been having issues with this word, counterexample. It's like an example, but it goes counter to what we're saying. So basically, when you have a conditional statement, if this is true, then this is true, a counterexample would say, yeah, this is true, but then this is false. So I'm saying b is less than or equal to 5. Well, this would make it true. This would make it true. Those can't be counterexamples. Here, b is 6. That is bigger than 5. So that's going to make this false, which is what we want. Let's plug it in, make sure it's true over here. So a is 2, b is 6, 8 is equal to 8. So that does make it true. That is a counterexample. If I plug 6 in here, this guy is true, this guy is false. Okay. Let's talk about converse, inverse, and contrapositive. These are on your little cheat sheet that I gave you. So this is your original statement. If P is true, then Q is true. My converse is if Q is true, then P is true. My inverse is if P isn't true, then Q isn't true. And my contrapositive is if Q isn't true, then P isn't true. Again, you do not have to memorize that. It's in your little cheat sheet that I gave you, but you do need to figure out what P and Q are. So identify the converse to the statement, if cats fly, then ducks bark. So we start off with our hypothesis, which is if cats fly is our hypothesis, then ducks bark is our conclusion. So to do the converse, I just have to swap those guys. So if ducks bark, okay, our conclusion now comes first, then cats fly. We just swapped around P and Q. All right. Identify the inverse of the statement. If a triangle has 3 equal sides, then it is equilateral. So again, the first thing you want to do, let's identify our hypothesis and our conclusion. So hypothesis is it's a triangle with 3 equal sides. Conclusion is it's equilateral. So the inverse, I'm going to take my original statement, my P and my Q, and I'm going to negate them. I'm going to say not P. I'm going to say not Q. Okay? So if a triangle doesn't have 3 equal sides, so let's take this first one, then it isn't equilateral. So that's going to be A. Okay? So 10 and 11 is kind of doing in symbols what we've kind of been doing in words. On your cheat sheet, I gave you this. I said, the law of detachment says this. If we have the statement, if P, then Q is true, and P is true, then Q is true. Well, you'll notice these are all big if-then statements. Okay? So we want to find something where this is my hypothesis, that this is true and this is true. So that's going to be J right here. If this if-then statement is true and P is true, then we get to say that Q is true as well. That's the law of detachment. So if these two things are both true, then we get to say that Q is true. Law of syllogism. Okay, we've talked about this. If this statement is true and this statement is true, then this statement is true. So let's see where we can find these statements. Hey, this and this, if these are both true, then we can say that this is true. All right, let's look at number 15. Okay. Measure of A is 10, measure of B is 10, then measure of A equals measure of B. Well, look what we've basically done here. Okay. We have this statement right here. And then instead of 10, I put this instead. I replaced it. I substituted it. So this is the substitution property. All right. Number 18. You should be able to identify these. These are what we call vertical angles. And based on the vertical angle theorem, we know that these two guys are equal. They're congruent. So if things are equal, set them equal. Okay. 21. If 1 is twice measure 2, find measure 1. Here's what I like to do. I'll call this X. This is double this one. This guy is twice of this one. So the angle, twice the angle. Okay, now what else do we know? If we add these up, these should equal 180. All right, that's all the starred problems.